Hello and welcome to another one of these ADD recordings. Today we're going to be looking at some examples of domain. If you remember, I told you guys, if you saw the concept video, to look out for three basic scenarios. One was look out for any denominators that you might encounter in your problem. And if you had a denominator, what you were to do was to set that denominator not equal to 0 and solve. If you want to set it equal to 0 and solve, and just know that it's not part of your domain. So it'll be everything but where that denominator equals 0. And then the next scenario to look out for was the square root. If you have a square root, you make it greater than or equal to 0. Don't forget to keep an eye out for powers of x greater than 1 or fractions under the square roots. And then finally, if you had a combination of the first two rules, the square root in the denominator, you would just set it greater than 0 because it cannot equal to 0, but it has to be positive. So by using these three basic scenarios, you should be able to do most domain problems. So let's look at some basic examples. The first one we're going to take a look at is this one here, and it's the function of f of x. It's got 3x over 5x minus 10. Well, right away you should notice that there's a denominator here, right? So what was the rule for the denominator? Set whatever you got not equal to 0 and solve. Sorry, I shouldn't skip any steps just in case. To get that 10 over to the right-hand side, you have to do the opposite of how it's connected to the x. It's subtracted, so you need to add that 10 over to both sides. That's how that just happened. And most of you are familiar with that, but that's fine, just for those of you that aren't. That 5 is multiplied, so to undo the multiplication, you divide both sides, and you end up with x cannot equal 2. So everything is defined except 2, because when I plug in 2 here, I'm going to get a 6 over 0, and that's a no-no in math worlds. So that's singularity, can't have it. So here we have an interval notation. We would start at negative infinity, and we would go to negative 2, and that would be joined with, oops, sorry, it's a positive 2, to infinity. Let's see if I can get an eraser in there. Beauty of the digital world. Okay, so these parentheses mean up to, but not including. Make sure you know that distinction, because if it was a square bracket, that would mean it included that number. So you can never include infinity. So it's not including that number. I can't include that 2 because that's what we just found out in this problem by doing the domain work. Let's look at the next example. The next example is just a polynomial. Do you see a square root there? Or an even root? Do you see a denominator? No. So the answer right away can be written of all real numbers, or you could have written negative infinity to infinity. Any number I plug into there is okay for that function. Now let's look down here at this problem. This one here has the combination of both rules. So the way rule 3 said, we would take whatever's under the square root, pardon me, whatever's under the square root, make it greater than 0, and then you solve the inequality. So what is the opposite of that positive 9? How would I get it to the other side? I would subtract that 9 on both sides, leaving me with a negative 3x is greater than a negative 9. Then I would undo that multiplication by dividing that negative 3. And that would leave me with x. Now, don't forget, whenever you divide by a negative number like that, You have to change the direction of the inequality. Okay, anytime you divide by a negative number, or if you flip both sides, that's when you got to change this direction. So if we were looking at a number line, this is telling me that I can start at 3. It has to be an open dot because there's no equal sign. We cannot equal 3. But everything to the left, let's do a different color. Oh, not sure why that happened. Updates, we don't need updates. Sorry about that. These are rough draft videos. I will be making more professional videos later when I get better equipment. So here, I needed to shade in a different color. The domain would be everything to the left of 3. An inequality says x is less than 3. The way I remember them is that the smaller point points to the smaller number, whereas the bigger side of this sign points to the larger number. So everything x has to be smaller than this cap, the 3. All right, so I hope these examples have helped clarify things. Again, the key is to know your basic scenarios. If you know those, then you can just tackle the problems pretty fast. All right. I'm going to do another example video that's a little bit more intermediate, and those of you that want to check out the advanced one, feel free. Hope I've cleared up any confusion. Practice, practice, practice. Thank you, and have a nice day.